Hello children. In this video, I'm going to explain few questions from the exercise 1.2 from class 10. Before entering to the exercise 1.2, you need to understand a few concepts. Okay. So this is fundamental theorem of arithmetic. What it is saying? The statement is important. There is no proof required for this theorem. This statement, understanding this statement and application of this statement is important. Every composite number can be expressed means factorized, as a product of primes, and this factorization is unique, apart from the order in which the prime factor occur. I suggest everyone to understand and underline in your textbook. Okay, already they have given a bold, but this is very important. Every composite number, composite numbers other than the prime numbers, which have a composite number will have a more than the two factors, one and itself. What is a prime number? A number which contains one and itself as a factors, then that number is said to be as a prime. So other than the prime, all other numbers are composite. Of course, one is neither prime nor composite in the number system. A composite number, take a composite number that can be expressed as a product of primes. So that composite number you need to split and write it as a product of primes. That product of primes is that factorization should be unique. You cannot divide much further. That is the final one. Apart from the order in which the prime factor occur. Okay, for example, see here, 210 they factorized. 2 into 3 into 5 into 7. 2 3 is 6. 6 5 is 30. 37 is 210. Isn't it? So 2, 3, 5, 7 are the prime factors for the 210. These are prime numbers. So you cannot split much further. 2 you cannot write much further. 3 as well as a 5, 7. But you can change the order and write. 3 can come first, or 7 can come first, or 2 can come first. But this is the unique factorization. So this is what they said. Every composite number can be expressed as a prime product of primes, and this factorization is unique, apart from the order in which the prime factor occurs. Okay, this should be unique. This is what fundamental theorem of arithmetic. Next, another concept. HCF and LCM. How to write a HCF and LCM by prime factorization method is important. First, HCF is highest common factor. We can also call it as a GCD, greatest common divisor. Both are same. See, HCF can be find out in many ways. But like a long division method in earlier classes, we found like a long division method, of course, prime factorization method, etc. But in this class, you are going to find out the HCF by prime factorization method only. How? This is very simple. Product of the smallest power of each common prime factor of the numbers. See, first of all, you will take the numbers, different numbers. You will split them into a product of prime factorization. See, 2 2 is a 4, 4 3 is a 12. So 12 can be written as a prime factors 2 into 2 into 3. This 2 into 2 is simply 2 square, 3 is a 3. Okay, 18 in the same way. 2 3 is a 6, 6 3 is a 18. So 2 power 1 and 3 square. Now HCF means smallest power of each common prime factor of the number. What is the common factor? CF means common factor, right? What is the common factor in this? 2 and 3 both are common factors. Okay, smallest power. When you are comparing these two numbers, which is the smallest power? 2 power 1 or 2 square? 1, obviously. So 2 power 1 into, in this 3 square or 3 power 1, which is the smallest power? 3 power 1. So we will take this. So we will take the common factors which are available in the both the numbers, and with their smallest powers, not the highest powers, smallest powers we need to take. So now 2 power 1 and 3 power 1 is nothing but 2 3 is a 6. Now LCM, completely opposite. All the factors you need to mention. What are all the factors in this number? 2 and 3. And of course in the 18 also 2 and 3. So both the factors you will mention 2 into 3. With their greatest power. So here in this 2, which is the greatest power for the 2? 2 only. So we will write 2 square into, in this 3 power 1 and 3 square, which is the greatest power? 3 square is the greatest. So we will take 3 squares. So 2 square is a 4, 3 square is a 9, 9 4 is a 36 is the LCM. Remember, LCM means least, but you need to take the greatest powers. HCF means highest, but you need to take the opposite word, smallest powers. Okay, here you need to take the common factor. In LCM you need to write all the factors. Okay, so when we are solving more exercise questions, you will come across with this and you can easily remember this. Okay, now let's solve the exercise 1.2. First question, express each of the following numbers as a product of its prime factors. These numbers we need to find out the product of the prime factors. Let's take all these questions on my board. Okay. Now for 140, you can do it in a number of ways. And one question I'll say, like LCM method, one question I'll say in a different way. So first one, what are the prime numbers? Prime numbers we all know, right? What are the primes? 2 is a prime, 3 is a prime, 5 is a prime, 7 and 11, 13, 17, 19. Below 20, we have 8 prime numbers, right? So with prime factorization means with one number after the other, we need to check and split this. With any numbers. Okay. So for this, I'm taking a 2. 2 sevens are 14, 0 is a 0. Now again, 2, 3 is a 6. 6 gone means 1 is remainder 10. 10 means 2 5 is a 10. In 35, 2 doesn't go. So you can pick up another number which is having a units place 5. So I will divide with the prime number 5. 5 7 is a 35. So 7 is a prime number, 7 1 is a 7. So 140 is equal to, how many 2's we got? 2 2's. So 2 square. How many 5's we got? 1 5 into 7 power 1. This is the prime factorization of the given number. Okay. Now, this one another model I'll explain. Okay. First, we will take a 2. 2 is a prime. So, box or circle it. How many times we can divide? 2 sevens are 14. 1 is remainder 16. 2 eights are 16. This is not a prime. So, don't circle or box it. Again, you need to split this. Hence, it is ending with the 8. So, you can still divide with the 2. Again, this is the prime. I am boxing it. 2 times, how many times? 2 3 is a 6, 1 is remainder 18, 2 9s are 18. Okay. Now again you need to split this. This 2 doesn't go, take 3. 3 into 3 1s are 3, 3 3s are 9. 3 is a prime number I boxed, and whatever the factor I got, 13 is also prime number. Okay. So now nothing is here to split. So this is our final answer. We can put it in this way. 156 is equal to how many 2's? Only boxed numbers. You should not write these numbers. Only boxed numbers. That means prime numbers. 2 square times 3 power 1 into 13 power 1. This is our prime factorization. Next. So we can do either of any method. Either this or this. According to the comfortable. Okay. Now this one. This is hence ending with the 5. So we can simplify with the 5. 5 7s are 35. 35 gone means 3 is remainder. 32. 5 6 are 30. 2 is remainder. 25. 5 5 is a 25. Next 5. 5 ones are 5. 2 is the remainder. 26. 5 5 is a 25. 25. 1 is the remainder. 5 3 is a 15. Now, if this is not divisible by 5. So, it is not divisible by 2. Check. 3 goes or not. 5 plus 1, 6. 6 plus 3, 9. 3 goes. Yeah. So, 3 5 is a 15. 3 1 is a 3. 5 plus 1, 6. Again, 3 goes. 3 1s are 3. 2 is remainder. 21. 3 7s are 21. 17 is prime number, so it can be divided with the 17 only. So 3825 can be written as 5 is how many? 2. 5 square into 3 is how many? 3 square into 17. Acha, see here, 3 is a small, 5 is bigger than the 3. So there is no rule that you need to mention this factor first and this factor second. So irrespective of the order of the primes, you can represent this in a unique way. Okay. So now this one also we can do with the 5 only. 5 1 5 0 times 0 times 5 1 5. Which one we can divide? 1 plus 1 is 2. 3 doesn't divide. 5 can't divide. Next is 7. 7 ones is 7. 3 is remainder. 30. 7 fours are. Yeah. So we can go with the 7. 7 ones is 7. 3 is remainder. 37 fours are 28. 2 is remainder. 21. 7 3 is 21. Okay. Now, which one? 7 doesn't go. After 7, it's 11. Yeah, 11 goes. 11, 1's 11. Gone means 3, 33. 11, 3 is a 33. 13 is a prime, so it can be divided with 13 itself. So 5005 can be written as, see, these are all single times repeated. So 5 times 7 times 11 times 13. This is the prime factorization. Now, last question in this, 7429. See, this is not dividing with the 2. Check with the 3, 7 plus 4, 11, 11 plus 2, 13, 13 plus 9, 22. It is not divisible by 3 also, 5 also, 7 also, 11, 11, no, 11 after 13, no. Next, 17. Yes, we can divide with the 17. 17 fours are 56. 56 gone means how much? 56. So 4, 60, 68. 17 fours are 68. 68 gone means 68 gone means 2 plus 4. 6 is remainder. 62. 3 times. 51. 51 gone means here 59. Okay, 7 times. 119. Next. Again, which table goes? 19 goes. 17 after 19 goes. How many times? 2 times 38. 38 gone means 2 plus 3. 5. 5 is remainder. 57. 3 times. 23 is a prime number. So 23 ones are. So 7429 can be factorized as a 17 into 19 into 23. So simple, right? Either of the method you people can follow. Now let's see next question. Find the LCM and HCF of the following integers by the prime factorization method. In each question, 3 or 2 numbers they have a given. First, we need to prime factorize those numbers. Then we need to find out the LCM and HCF. Okay. First, what are the prime factors of 12? Small numbers we can write directly. 2, 6 are 12. 6 can be written as a 2, 3. This is a 6. That means this is 2 square into 3. Next, 15. 15 is nothing but 3 5s. The 3 and 5 are prime numbers. 3 power 1, 5 power 1. Next, 21. 3 sevens are 21. 3 and 7 are prime numbers. Now, LCM. L means lowest but opposite. Highest powers we need to take. Highest powers of what? All the factors. Whatever the factors present in 12, 15, 21, we need to take. Here 2 and 3 are there. I am writing 2 into 3. Here 3 and 5, but 3 is mentioned, so 5 you take. Here 3 and 7, 3 is mentioned, so 7 you take. So all the factors in 3 numbers I have written, but we need to mention with the greatest powers. So 2 greatest power is what? Square only. 3 greatest 1 only. Here also 1, here also 1, everywhere 1 only. 5 greatest 1 only. 7 greatest 1 only. So the LCM becomes 2 square is a 4. 4 3 is a 12. 12 5 is a 60. 67 is a 420. So LCM is 420. Now we need to find out the HCF. HCF, highest common factor. So common factors we need to write first. Then opposite to this highest, smallest powers we need to consider. So common factors with the smallest powers. So what are the common factors? Common factors means in 3 numbers it should be present. That factor should present in 3 numbers. Here 2 is there. Is it present here? No. 3 is here. 3 is here. 3. So 3 is the common factor. So 5 is not present in this both. 7 is not present in this both. Only 3. Common factor with the smallest power. What is the smallest power of 3? 1 only. So HCF is also 3. 3 power 1 is nothing but 3 only. Like this. Let's do the next question. 17. 17 is a prime, right? So 1 and 17 only the factors. Okay. 23 is also prime. So 1 and 23 only the factors. 29 is also prime. 1 and 29 are the factors. LCM. Write all the factors. 17, 23, 29. Actually, no need to mention 1. Okay. Next. So, we need to multiply this. 17, 23 and 23, 29. This gives you 11,339. HCF. Common factor. What are the common here? 1 only common factor. And greatest power. Here 1 only. Greatest power also. 1 power 1 is nothing but 1. So HCF is 1. Next. For 8. What are the factorization of 8? 2 4s are 8. But 4 can be written as 2 2s are 4. So this is the prime factorization, which is nothing but 2 cube. 2 is repeated here 3 times. 9. 3 3s are 9. Prime factors are 3 and 3. 3 square. 25. 5 5 is a 25. Perfect square. So 5 square it can be written as. Let's write LCM. All the factors 2 3 5. We'll put 2 into product of all the factors. With their L opposite is greatest powers. So their greatest powers are simply this. So that means what? 8 into 9 into 25. How much 8 nines are? 72. 72 into 25 is how much? 25 is 1800. 180. Now HCF. Write the common factors. What are the common factors? Is there any common here? No, nothing. 2 is not present anywhere. 3 is not present anywhere. 5 is not present anywhere except this number. So if there is no common factor, we will take the HCF as 1. Next, 72. 2 into 36. 36 can be written as 2 into 18. 18 can be written as 2 into 9. 9 can be written as 3 into 3. So this is 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 3s are 72. Correct. So this is 2 cube, 3 square. Let's write 1 at 8 also. 2 54s. 54 can be written as 2 27s. Sorry, 27 can be written as 3 9s 27. 9 can be written as 3 3s. Okay. So 2 square into 3 cube. Answer. LCM. All the factors. 2 3 here, 2 3 here. So all the factors are 2 and 3. Product of the factors. With the greatest power. 2 greatest power is 3, na? So we'll take 3. 3 greatest power is also 3. 2 cube is 8. 3 cube is 27. 8 27s 216. HCF. Common factors. Common factors what? 2 is present here. 3 is also present here. So 2 and 3 only. H opposite. Smallest power. Which is the smallest power? 2 power 2 is the smallest. In comparatively in the 3 also power 2 is the smallest. So what is the HCF? 2 2s are 4, 3 3s are 9, 4 9s are 36. 36 is the LCM. Next question. 306. If we are feeling difficult, big numbers we can write in this way. 2 1s are 2, 10, 2 5s are 10, 2 3s are 6. Prime now. This can be written as 3 table. 3 5s are 3 1s are. This can be split it as 3 7s are. So 3 and 7 are primes. So 306 is equal to 2 into 3 is multiplied twice. Okay. Now 657 also big number. No, so first we will write. We are not giving a direct trial here. We may do the mistakes. So let's do here 657. 6 plus 5, 11, 11 plus 7, 18. So 3 goes, right? With 3. 3 2s are 6, 3 1s are 3, 2 is reminder. 3 9s are 27. Now this we need to do. 3 table again. 3 7s are. So this 73, nothing goes. 73 is a prime, right? So we'll stop dividing. So 657 can be written as 3 square into 73. 7 is written as 3 square into 73. Am I right? Yeah. So now write LCM. All the factors 2, 3, 17, 73. With the highest power, 2 highest power is 2 only. I mean 1 only. 3 highest power is 2. 17 once only. 73 also once only. So we need to multiply. 3 square is 9. 9 2s are 18. 18 and so the total multiplication we get 22,338 is the LCM. HCF. Write the common factors. What are common? 2 is not present here. It's not common. 3 is present. 17 is not present. 73 is also not present. So only 3 is the common factor. And its lowest power is 2. So 3 square is 9. So this is the HCF of the given numbers. In this way, we can find out, we can do the prime factorization and find out the LCM and HCF. LCM and HCF. Remaining questions we will see in the next video. Keep watching. Thank you.